Here are our notes for Lesson 4, Day 3. And we're going to consider looking at the distributions of 3 lists and making a determination of how much better one is over the other, using a comparison of means or medians, and definitely checking if the distributions for each list is skewed or symmetric. Using the calculator, and actually I used a website. I just plugged in, standard deviation calculator, and the first website that came up has been pretty solid. But if it doesn't, try another one, or definitely learn how to do this on the yellow calculators. I use them in order to calculate the mean and median for vitamin A list, vitamin B list, and vitamin C list. For vitamin A, the mean, remember that's signified by X bar, is 8.8. And in order to find the median, since there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers, half of the numbers will be above the median, so 1, 2, 3, 4, 5, and half will be below, 1, 2, 3, 4, 5. So right in this little window is the actual median. It doesn't fall on either of these numbers, but it's in between them. And the only way that's possible is if it's 8. For vitamin B list, the number of jars of vitamin sold, the average mean is 13.8. Note, by the way, this matters, but this is called the arithmetic mean. Just a comment for now that may never show up ever again. But when we say arithmetic mean, we mean add up the number of numbers and divide by the number of numbers. The median for vitamin B list, it's got to be between these two numbers. And that's the same logic as before. 5 numbers below, 5 numbers above. And the only way there can be a number between 14 and 15 is if that number is 14.5. For vitamin C, same idea. I plugged these numbers into a calculator somewhere, standard online, whatever, and I got 10.1 for the mean. I'd call you all average, but that's just mean. That's too many times I've told that joke. In order to find the median, same as before, there's got to be 5 below and 5 above, 10 numbers in the list. So in between 9 and 10 is the actual median. It's neither 9 nor 10. And there you have it. As we move down the table, in the next box, we actually jump into the classwork. We want to describe the distribution. I'm going to leave this column blank, the distribution type, and I'm not going to fill that part out yet because the preferred center value, the distribution type, it depends on the shape of the distribution. But I also knew that I was going to need to record the standard deviation and IQR for each. So for vitamin A, the standard deviation is, remember it's signified by that symbol, sigma, that it's 2.82. For vitamin B, the standard deviation is 2.86. And for vitamin C, 2.89. I had to go back to the actual lists themselves to calculate IQR. I mean, IQR can be given to you, but you still have to work for it a little bit. And in order to find IQR, I look at the bottom 5 numbers and I find the middle of those bottom 5 numbers. I look at the top 5 numbers and I find the middle of those top 5 numbers and I just subtract 11 minus 7. And in the space here, I'm going to put a 4. Do the same thing for B and C. I'm just going to work through them quick and then answers that 11 is the middle of these 5 numbers, the bottom half, and 15 is the middle of these 5 numbers, the top half. So 15 minus 11, 12 minus 9, 3. So in this table down here, I'm putting a 4 for the IQR of vitamin B, and I'm putting a 3 for the IQR of vitamin C. This 3 might tell us that the shape of vitamin C's distribution is tighter, more compact to the middle. You're going to need some extra color. I'm going to recommend having some extra color for what we're going to do on page 14, the next page. And I'm still leaving these 2 columns blank until after I've had a chance to look at the shape of the distribution. So please go ahead and get some color. I'd say like a highlighter, if anything, or some markers. I've got some pencils that are pens that I'm going to use. So on the next page, I want to create the histograms, one on top of the other, in this space. And there's some math that we need to keep in mind as you create histograms. Something like your range needs to be considered, your bin like the number of bins. This is really a fancy old person term for garbage pail, like how big of a section are you going to do. A better word might be the number of intervals. They literally use bin though, because it's like you throw something away, you throw it in a garbage bin. You also need to talk about your bin, there I'm using it again, your bin width, let's not use the word, the interval width. So along this line, we're going to make sure that we have intervals, and we got to choose the right number of intervals. And you know what? Approximately 5 to 8 is the right number of intervals. And then the width of your intervals is your range divided by the number of intervals that you want to use. And then just kind of round nicely. Round nicely. That's the last one. It doesn't have to be perfect, but it has to be, done well enough. So using my information, I look at these three lists of numbers on the other side. The smallest number in the list is 5. And the biggest number in the list is 19. So I guess round rather nicely. If I go from 5 to 19, that's 14 spaces. 5 to 20 is probably easier to calculate. 20, 15 spaces. Let's go 5. Let's go, 5 being the number of bins, and so 15 divided by 5 means that this needs to be 3 intervals. Sorry, I'm doing math on the screen. There it is. Let's say that the range, which was approximately 15, so 15 divided by, let's choose 5. 5's, it's arbitrary in our choice. We could choose any number, but I'm going to choose 5 because it seems easiest. 15 divided by 5 means 3. So here we go. Scale. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? 6, 7, 8, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 22, 21, 22, 23. Yeah, there's more. We don't really care about it. But the goal now is, the reason why I have these 3 colors, because one of them is going to be vitamin A, and one is vitamin B, and one of them is going to be vitamin A. And so I'm going to raise a bar going up from the scale line according to how many numbers are in this list estimation. And every time I land on a number along this interval, I'm just going to put those in the next pile to the right. A right binnable number. So between 5 and 8, I guess between 5 and 7, I have 1, 2, 3, 4 numbers. So since I have to put 3 histograms one on top of each other, I'm just going to use this section right here and say go up 4 spaces. 1, 2, 3, 4. There's the bar that represents vitamin A. From 8 to 11, there's 1, 2, 3. Remember, 11 goes to the next number up, the next pile up. So 8 to 11, that means 8 and 9 are in this section. So 1, 2, 3. Doing it on graph paper probably a better idea, but whatever. That's the number for A. And then 11, 12, 13. So there's only one 11, and there's 13, 14. So only, let's see. Wait, let me count again. Sorry, the flipping. So there's 11, 12, 13. These 2 numbers are in the same bin, and this one's not. It's in the next one up. So we're going to go, forgive the flippingness. Here we go. There and there. That's for A. And then that's for A. There's my distribution. There's an issue that I have with this. Technically, in a histogram, all of the bars should touch. But I also have to do B. And so that's where I'm going to go back to the other side. And in between 5 and 8, B doesn't have any numbers between 5 and 8. But if I look at 8, 9, and 10, remember 11 will go up. How many numbers does B have between 8? Oh, none. That's 2. 10 and 10 will go between the gap of 8. And so 1, 2, 2. There's B. Sorry, there's B. Is B. Then I'm going to look at number of numbers between 12, and 13. If it's a 14, it's on the next pile up. So 11, 12, and 13. How many numbers in B are 11, 12, and 13? 13. 2. So create R. Spaces high. This might be Lagrange conventional and not actual conventional, but hopefully get the idea. And I'm getting a little bit more like coloration. So it's 4, 15, and 16 are in the next interval. Where's our 14, 15, 16? 1, 2, 3, 4. So make a bar. 1, 2, 3, 4. Roughly the same height across. We start to kind of see another picture for how the B histogram looks. A definitely goes like this. B might go a little, boom. Coming back. Flipping back again from 17 to 20. So how many numbers are 18, 19, 19? 17, 18, 2 of them are 17, 18. I guess it's what? It's the middle. So here in the middle, 2 is B. Okay. This is symmetric. Yeah, there's a little over here, but really have a large set of numbers. So rather symmetric. Okay, now I'm going to bring in the third one. Between and 8, so 5, 6, 7. There are no 5 7s for vitamin C. But between 2 to 11, 8, 9, 10, there's 1, 2, 3, 4, 5, 6. I gotta make 6 spaces high. 1, 2, 3, 4, 5, 6. This many between 8 and then there's that many numbers between 8 and 11. Okay, so now I go 11 to 14. So that's 11, 12, 13. 11, 12, 13. 2, 3, 4. 1, 2, 3, 4. The only location for C. I guess I'm gonna solid this one in. This is really compact, and we saw that because its IQR was 3, as in 50% of the data free spaces of it. So I guess technically we're gonna call that symmetric. It's really close together. It's almost another word we would use called uniform. And so because vitamin C is such uniform, there's definitely not like skewness to it where it's obvious. We'll just assume it's symmetric. So there. Mean is the measure of center. And also a question was asked yesterday by a rather intelligent individual. Are standard deviation and IQR sometimes it's kind of nice when they are. Standard deviation is calculated from the average though, and IQR is from the median. Let's go back to vitamin. Vitamin B is a histogram that looks like this. And there's a high point in the middle. There's some low points on the sides, but it's kind of even. It's a little weird, but not that weird. And so B is also symmetric. And that means that mean is an appropriate measure of center. A has a histogram that looks roughly like this. Tall, shorter, and therefore there's a skewed to the right nature, and because it's skewed, median, I'm going to put R for right, median is the best measure of center. In fact, that's true because the median is going to be somewhere here for A, but because it's skewed to the right, the mean is going to be larger. It's going to be somewhere here for A on that side. Skewed to the right means mean is larger than median. Believe me? Check it. Plug the numbers in. Box plots really show the median and IQR. And that's really helpful because, for example, if we did a box plot for A, it looks something like this. And that's easy to longer, really compact on the left side, and see this box plot looks something like this, and so therefore it's easy to skew right. Look at how there's a long whisker right the right side of the graph. B have a box that looks something like this. That's symmetric. C would have the same thing. So when we create histograms, it's important to think of scaling bottom, how wide you're going to make each calculation. And trust me, I did this like just the Brent way. There's a better way to do this, and I'll show you when I'm actually there. I'm going to take a look forward. I think we can use ones together in the next video.